Okay, fundamentally what we've been doing lately in 2.8.1 yesterday and 2.8.2 here today is looking at functions and seeing when they're below or above 0. Do you get I just made you a function on the xy axis? Do you see when it's above 0? Some of you are not with me. Get with me now so I don't have to publicly embarrass you. All right. That is above 0. That's also above 0. So if this was -5, this was +5, and this is 8, would you write me the intervals where this function is greater than 0? Just look at the picture. It's really easy to tell. You should have said that it was greater than 0 between -5 and 5. That's for sure. And also between 8 and infinity. Raise your hand if you knew that. Okay, good. Now, do those endpoints work or not? No, because I said greater than 0, and those endpoints are 0. So how could I make it so the endpoints would have to work? Add an or equal. Now I'd need to change almost all of my parentheses into what? Brackets. It's the only difference then. These endpoints actually work now. Not on the parentheses, not around the infinity, of course. All right, here's a kind of a trick one. See if you can catch this. I want to know when, if this is -5 and this is 8, when is this function less than or equal to 0? Turn it my way and I'll tell you if you did it right. Got one part right, one part wrong. You've got one part of it right. You get one part of it right. You got one part of it right. I wasn't saying that one of your numbers was wrong, but you're forgetting one of the solutions. You got them both. Nice. Warm but not right. You've got them both. Nice work. You figuring them both out. Good job. You figured them both out. You figured both solutions out. Yes, that works. Yes, that works. Yes, that works. Yep. Yep. There's 2 parts to this. Yes. Yes. Now it's like close. You got 2 parts, but you missed one of them. You missed writing one of them right. Okay, so here's the 2 parts. Would you agree that's below or equal to 0 if I include that? Okay, so then it's from -infinity to -5, and pretty much everybody said that one. And it has a bracket on the -5, by the way. I wasn't clear. Some of you it's hard to tell if you're brackets or parentheses, but anyway, it's supposed to be a bracket. Then the one you forget is this one, because see, 8 also is equal to 0, so you have to union it with 8. Now, some people put 8 comma 8. That works, but if you just put 8 in a bracket, that works too. Why wouldn't you want to put 8 in the parentheses? Because then you're specifically excluding 8 and saying 8 does not work. You don't want to do that. Brackets. All right. You get why that's kind of a trick one? Everybody sees this as underneath 0, but they forget about that. Equal to 0 and therefore qualifies also. All right. Now, some of these are easy to graph in your head. That's my function. If I want to know when that's greater than or equal to 0, if you just graph that, you can tell really quick because, you know, those pictures make it easy. So let me just show you how I would graph this one. I'd say, okay, the root on that one's 2, and the root on that one is -4. I put dots there and there. Do you remember how to do this? This is degree 3, so I know it's going opposite directions on the ends. You remember how it's positive in front, and therefore it's going up on the right? And these are both cut-throughs, right? Oh, one of them is a cut-through, and the other one is a bounce. Okay, so I'm cutting through at which one? Let me see. I'm cutting through at the 4, and I'm bouncing off the 2. Bounce. cutting through. Now, do you get how I just sketched that really quick, but yet I can now tell where my function is greater than 0 or equal to 0? Okay, and this is at -4, and this is at 2. Everybody write me the answer as an interval then. I saw that. Put that on my desk. Busted. You might want to get up. I'd hate to have you drop it. Okay. Look on the board. All right. Yes. Yes. Turn it my way. I'll tell you if you got it right. Yep. Doesn't include that number at the end. Don't do that, because that number's already in the group automatically. Yep. Except that number's already in the group. You're sort of like saying everything from here to and then also this other number, which is already in the group. Yep. Yep. Nope. Let me show you. It just goes from this number all the way to that number. Skips that in between stuff. Yep. 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 Yes, that's sort of like saying from 1 to 100 works, and then from 100 to infinity works. That means the whole thing works. Yes. Okay. So here's what I was seeing. Everybody knew that it worked between -4 and 2. So a lot of people wrote -4 to 2. And the problem with that is that it keeps going. It keeps working. It doesn't stop working at 2. It's still or equal to 0 at 2. So it just keeps going. Don't stop it in 2. Keep going all the way to infinity. That was the right answer. -4 to infinity. You don't want to break it into 2 chunks unless you have to. Like if that 2 had not worked, how would that not have worked? If I changed the problem to say greater than instead of greater than or equal to, then you would have had to say up until 2 it worked, and then it stopped working, parenthesis, union with 2 to infinity. That's if I changed the problem to greater than. Okay, so what if you can sketch it yourself easily? You should. It'll make it way easier. I'm going to give you another one like that. Sketch that one. Figure out when it's greater than 0. Sketch it. The sketch thing, I think, is way easier than testing it every single interval. And besides, you guys were awful at testing intervals. So maybe this will be a better way to do it. Maybe you'll make less mistakes on this one. Just to clarify, you could have done this with a number line and then testing intervals. Hopefully you identified the key spots. We're at 5 and -3. But I'd say graph it and you'll more likely get it right. Can you zoom in on just the answer, please, when you're done? Yep. Some of you, I can't tell if it's brackets or parentheses. I think you're mostly using parentheses, which would be a good thing. Nope, the beginning part of your answer is not right. Yes. Oh, wait a minute. The beginning part of your answer is not right. Yes. The beginning part of your answer is not right. Starts later than that. Tell you guys. Nope. Yep. All right. Okay. Here's where I think your sketches were for some of you were wrong. Would you agree it bounces at the 3, -3, I should say? It has to bounce at the -3, otherwise you're not going to be doing this right. And do you get it's got a lead coefficient that's positive, and therefore it must be going up on the right? How can it be going up there and bouncing off of this? Well, if it cuts through here and then bounces, that means it's only above 0 from 5 to infinity. And is it above 0 at the 5? Does 5 work, in other words? Now, and the way you can tell is because there's no or equals to. If there's no or equal, you won't have a bracket. All right. I'm going to change this problem with this tiny, tiny little thing, and it'll totally change your answer. Everybody erase just the answer. Just the answer. I'm changing this to or equals. Now tell me the answer. Now, when is the function greater than or equal to 0? Yes, except put parentheses around that number. Sorry, not parentheses. Brackets. Brackets. Yup. 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 It's actually at negative fact. Yup. 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 You caught it. Yup. 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 You guys can just put a single -3 instead of making 2. Just a single one's fine. All right. Yup. 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 Okay, good. I'm getting lots of right answers this time. So that's the spot that's now included that's easy to forget. -3 works, so I usually like to write that, sorry, brackets, union with 5 works also because it's or equal to infinity. There we go. Okay, now that's solving with a sketch. It's kind of in between actual graphing and solving it algebraically. What if it was graphing? If it's solved by graphing? Well, then really you just got something so nasty you would never want to have to try to sketch it. Plus 4, let's say -x 4, let's make it squared plus 4, and then it's greater than 0. Okay, if it's just really nasty like that, it's easily conquered with a calculator. You just graph this thing, and you see where the graph's above 0. Say it does that. Well, and you just got to identify all of these spots where it's above 0, which would be here, and there, and there, and have 3 little intervals for those 3 things. What do you need then? You need the calculator to tell you these spots, right? And that would be under second calculate what? The zeros. Okay, so if the calculator, when it says solve graphically, I'm not going to have you do that many of those. It's not something that's, I don't know yet, but my gut feeling is we're not going to have a calculator on the test. So those ones that you sketch are way more important than the ones you graph. So I'll have you try 1 or 2, but the graphing kind with the graphing calculator, all you need to do is know how to do second calculate the zeros to be able to find these spots, and then it'll be really easy to write your intervals. So if I give them to you, it'd be like this. -5, 2, 3, 4, and 7. I'd like you now to tell me, since I found the zeros for you, which I know your calculator could do for you, tell me what their answer is now. When is this function bigger than 0? Okay, you should have said from -5 to 2. Do you agree with my parentheses? Good. Because there's no or equal. If this, I changed this to an or equal, you'd have to use brackets, but I didn't. Okay, so from 3 to 4, and from 7 to infinity. I'm going to put unions between them, and there we go. Raise your hand if you understood that. Okay, good. Then let's move on to the last kind, which is solve algebraically, as in without a calculator. All right, so if I'm supposed to solve this thing without a calculator, you can do this algebraically by saying, okay, what are the zeros? How can I make this equal 0? You make a little equation. X squared plus 1 equals 0. I want you to solve that little equation for me. X squared plus 1 equals 0. Super simple. Please don't pull out the letter I, because even though I could be used, we're not going to ask you to find imaginary roots with only real answers. So, I know a lot of you are like, well, then how do you do it? Well, you can't. The point is, if you need real answers for this, you're going to end up with the square root of -1, and that's not real. So there are no real roots of this. Okay, so this part's not going to give me any roots. You'll see on the key, they'll just do that. Doesn't tell me any roots. That means if I'm trying to make a number line and make some roots, I'm down to only one possibility, and that's right here. Could that be equal to 0 somehow? Yeah, because I can set 3x plus 2 equal to 0. Solve that, please. That one you can get 0 from. It's a nice little fraction. Show it to me. I'll tell you if you're right. Yep, 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 yep. Okay. Subtracting 2 from both sides. 3x equals -2. X equals -2/3. There we go. So -2/3, the only important spot. Circle it. Does it work or not? Where do you look to find out if it works or not? The sign. Yes, you could plug it in. Way slower, but you'd find out that 0 is greater than 0. And is that true? No. So it does not work. Another way I can tell, if this doesn't have an or equals, it does not work. Empty circle. Okay. Now, which side does it work on? I don't know. That I should test for. It wouldn't be that hard. Pick any number. What's the easiest number in the world to test? You'd think it was 1. It's not 1. 0. 0 is the easiest number to test because it makes things cancel. If I put a 0 in here, the 3 cancels off. It's just 2 squared. Don't forget squared. 2 squared is 4. So is 4 greater than 0? So that worked. That whole side will work then. Do we assume the other side works? We have to test. It might work, it might not work. Yes, sir. Good question. If I put something in here, do you agree that no matter what I put in here, this is always going to come out positive? Okay. Now, let's talk about that for a second. Do you get that even if I made this thing come out negative, once I square it, do you get it's going to come out positive? Then this one always has to be positive, and this one, because it's being squared, will also always be positive. No matter what I put in, it's positive times positive, which will be bigger than 0. So logically, I can say both sides work. Now, could I have also just tested a number and find out? Yeah, I could stick in like -2 and find out. But remember, I wasn't putting it in here because I know that's going to come out to be positive no matter what. But I could put it in. -2 squared is +4 plus 1 is 5. That's +5. And this other side, if I put in -2, I'll have -6 plus 2 is -4. But then it gets squared. +16. 16 and 5, some big number that's positive, and it's bigger than 0. So it worked. Okay, there we go. There's that answer. Okay, so that's doing it algebraically. Could it have come out that one of these answers was like a square root or something? Yep. There's one easy root here that says greater than or equal to 0. There's one easy root here and there's one harder root here. Find the two roots, test your intervals. This is a very typical, it's kind of on the easy edge, so it's either an easy R3 or it's a hard R2. Started here because this part's 3. I hope you have a 3 on there. And then this other part, you're supposed to go, okay, well, he said set it equals 0, so x squared minus 5 equals 0. So x squared equals 5. So x equals square root of 5. So square root of 5 is some small number. It's like square root of 4 is 2, so it must be bigger than 2. But it can't be 3, so it's like 2 point something. So I'll put the square root of 5 right here. Everything I did was right, and yet I'm still wrong. There's another 0. What do you mean? Plus or minus? What do you mean? What are you talking about? You're right. Just explain it. Where did I screw up? When I did this square root on both sides, it's the absolute value of x equals square root of 5. I warned you that topic was going to come up over and over and over again. And people would keep forgetting to split it up into two answers. X equals square root of 5 and x equals negative square root of 5. There's two of them. So there's square root of 5. Here's negative square root of 5. Now I've got 1, 2, 3, 4 intervals that I'd have to test to see whether or not it works in there. And all of these spots work. I know that because of or equal to. Okay? And how do you test something that's between square root of 5 and 3? Ugh. Would you ever have to do anything that nasty? Oh, yes, you would. So you have to ask yourself, okay, well, I better make it just a teeny bit less than 3. So like 2.9, 2.8, 2.5 even, maybe? But how big is the square root of 5? Well, you have to think it through and say, okay, well, I know that it's 2 point something, so I better be careful, and maybe I'll just go with, like, testing 2.9 and seeing if that works. It's really not that hard. Once I put in 2.9 right here, I think you'll get the idea what's going to happen. Do you get, all I care is if it's bigger than 0 or not. This comes out negative. This comes out 9 squared is 2.9 squared is about 9 minus 5, which is positive. This is positive. This one's a neg. If I do a positive times a negative, my answer is going to be negative. Therefore, it's not greater than 0. Therefore, it does not work in there. All right. I want to go through that one more time because remember how I said you're terrible at testing intervals? That's why I'm getting lots of blank looks right now. Okay, so what's the point? You got to test something between here and here, and I knew that it had to be just a little less than 3. Because if I go down to like 2, now I'm lower than square root of 5. So I'm going to pick something that's just a little less than 3, like 2.9. I stuck a 2.9 in here, and I stuck a 2.9 in here. And I noticed I didn't get an exact decimal answer. That would take forever. I just figured out that it came out negative for this one, and it came out positive for that one. If any positive number is multiplied by a negative number, you get a negative answer, which is therefore not bigger than or equal to 0. Not. So therefore, it did not work. I crossed it off. Okay? Let's just do one that does work. Let's test the number 4. If I put the number 4 in here, 4 minus 3 is positive. Put the number 4 in here, it's a really big positive number. Then it's positive times a positive, which is a positive. And if it is a positive, it is bigger than 0. So it does work in there. And you have to test each interval like that and find out where it works and where it doesn't work. My happy place is in here, 0, because it makes everything so much easier. When I put in 0 right here, I get negative 5. When I put in 0 right here, I get negative 3. A negative times a negative makes a positive, which is bigger than 0. So it works in here. And I would guess that it doesn't work out here, but I better check. So let me try like negative 3 for out here. If I put in a negative 3 and a negative 3, this will be negative. And this one will be negative 3 squared, which is 9. 9 minus 5 is positive. A positive times a negative makes a negative, which is not bigger than or equal to 0, so it does not work. So final answer from negative root 5 to positive root 5, union with that spot, 4 to infinity. And I got to look close and see if I need brackets or parentheses. Ooh, it says or equal to. I need brackets. 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 There. That's a Precalc worthy question. There's been a lot of easy stuff. This one's hard. Why did I say 4 to infinity? Because oh, you caught me. It's supposed to be a 3 right there. I used my testing number. I should really have written that like really small and insignificant because that was a number I was just testing. 3 was the root. Thank you for catching that. Let me make sure I didn't make that mistake on the other end. No, these were the actual roots. Square root of 5 and negative square root of 5. Thank you for catching that. That's supposed to be 3. Okay, that's the tough kind. That's how you could actually make this stuff hard. Now remember, this is the algebraic manipulation test, and they're always the hardest kind. Your homework for today is 2.8.3. I'm going to pause for a second while I pull that up. Yes, a student caught me. It is 2.8.2 is your homework, not 3. 2.8.2 today. All right. So let's do the first one together. It always feels to me a little easier to get your homework done if you get the first one going. You don't get stuck there. All right, solve algebraically. So that means they're not supposed to graph it. Can you still graph it? I never know. But with your calculator, that'd be like cheating because you won't be able to do that on the test. But if you're sketching it, that would be okay. But this one's tough to sketch because you don't just like know what the root is right away there, do you? It's hard to know where it's bouncing, okay? Or if it even is bouncing. All right, so then a sketch kind for this, even though you could probably do it, it wouldn't be very fun. All right, so I got to try to figure out where the roots are for this and do it that way. X squared plus 1 equals 0. X squared equals negative 1. Square root, oh, square root of a negative. I won't be able to tell roots for that. This one, negative 2 minus 3x squared is equal to 0. I'm trying to find the roots, the zeros, so I'm setting them equal to 0. Adding 2 to both sides, negative 3x squared equals 2. Dividing by negative 3. And some people right there would have forgotten and took a square root. We can't do the square root until now. Now I do the square root, and I have the square root of negative again. I can't find any roots. That means there are no roots. That means it doesn't touch the x-axis. That means the graph is either all above this x-axis or it's all below the x-axis. How am I going to be able to tell whether it's all above the axis or all below the axis? Yes? Yes, if the lead coefficient is negative or not. I need to know that times that to know my lead coefficient. That's negative 3x to the 4th. Now you tell me, is it heading up or down on the right side? Because it has a negative as a lead coefficient. It's going down on the right side. Now, tell me logically, if this thing never touches the x-axis and it's going down on the right-hand side, and it's a degree 2 plus 2 makes 4. If it's degree 4, then it must be going down on the other side also, right? So you should be able to tell that that thing does all of its work underneath the axis. And therefore, when is it bigger than 0? Never. Because it'd have to be up here to be bigger than 0 or above the 0 line. So therefore, it's never up there, and therefore the answer is no solution. All right, do you get that the reason I didn't have any roots is because I couldn't solve these things? That's why I knew it didn't touch the x-axis, because I couldn't solve that or that equal to 0. There was no way to do it without negative square roots. Okay, so if it's not touching, then the only question is if the whole graph is up here and heads up on both ends, or if the whole graph is down here and goes down on both ends. And I knew it was down there because it had a negative in the lead coefficient. So I knew that the whole thing had to be down here. Therefore, no solution. All right. I'm going to clear off the board. And all right, slide it over to be able to see the choices. There we go. And now I'm going to slide down, and I'm going to say, the assignment's a little bit long. I'm going to allow you to skip problem 8 and problem 11 and 14. 8, 11, and 14 are skips for today. All right, So let's do like 9 to solve algebraically. At least these are nice numbers, so I can find the roots easily. That's going to be negative a half. I trust myself to do that in my head? Maybe now, yes, but on the test I might have taken the time to actually set 2x plus 1 equal to 0 and solve it. But I trust myself. It's negative a half. This one's 2. If I can't do that, I'm in deep trouble. And that one is positive 4/3. 4/3 is like 1 and 1/3. So that's in here between these two. Okay. Now, do they all work? No, none of them work, because it doesn't say or equal to. Empty, empty. Now, can I do the graph thing for this one? Yeah, I can. You can't use a graphic calculator, that'd be cheating. But this thing's a degree 3, so it's up on one end and down on the other. Looks like the lead coefficient would be 6x to the third. So this thing's a positive, so it's going up on the right. It's cut throughs all along, here, and here. Cut through, cut through, cut through. There we go. Now, can you tell where this function is greater than 0? I like that a lot better than testing all those intervals. How about you? Because when you do this, you're less likely to screw up on testing one interval and then write the full test wrong. Now, it's possible you could screw up making the graph, too, but personally, I think this graphing way is easier than checking the intervals. So where is it bigger than 0? I'd say in here, and from there on. So I would say it's from there to there, union with, oh, I can even do this, union with 2 comma infinity. And they're not always going to work out that nice, but it happens. All right, see the power of having a sketch? That you got nothing else out of today. I hope you get that out of today. All right, so the rest of the time is yours. I know there's not a lot, but you learned another one step closer to probably one of your harder tests from the semester. It's happening after break. Tomorrow, unfortunately, we can't just have a free day. I teach you another thing, but I will say it's easier than today. So tomorrow shouldn't be too tough on you. All right, that's all I got for today.